So for today, we're going to be doing a NLP exercise similar to the one we did last time, but this time we'll be building a classifier using logistic regression ourselves. So in the chat, I put a GitHub link. There are two files there, so just please go ahead and download them so you can have the code and then we can work through it together. And there's also a data set, so you'll have to download that in the same directory. It's not that large of a data set, it's only 20 MB. What we're going to be doing is, and this is a very famous data set, we have reviews from IMDb on movies, and we have these large data sets of reviews, I think 25,000 reviews, and we want to be able to detect the sentiment of do sentiment analysis on those reviews. So all the information that you'll need for this exercise is in those two files that I sent. So please go ahead and download them. I will share my screen now.
So meanwhile, just to we have a GitHub for Testopper, sponsored by GitHub.
Yeah, it's in the Testopper GitHub.
Yeah. For those who do not have access to the Testopper GitHub, you can actually send us the GitHub ID in the chat today, so we can add you into that GitHub repository or whatever the permission is required.
I've used this repository before, and everyone is able to access it. Can you confirm that that's an issue? Like, is everyone not able to access the files right now?
I'm able to access, but I have an account, so someone.
Yeah, let me log in.
Yeah, I just git cloned it. It's fine. I can clone it.
Yeah, even if you don't have an account, you can access this.
Right, Partha, you also have
No, I just tried doing it without a GitHub account and it still worked. So you can still download the files.
Okay.
I think the exercise folder here is open to everyone. I think. I'm not sure. Okay, and once you have the files, put them in the same directory, extract the tar file in the same directory, and import all of these. If you have already used the Anaconda package or already downloaded the Anaconda package, then these all libraries will already be installed on your system. So while you do that, let me just go over what the data set looks like. One second. So we have two data sets here. One is our testing data set and one is our training data set. And the way that they're structured is that each data set is composed of 25,000 reviews. And in each, the first half, so the first 12,500 are positive reviews, and the last 12,500 are negative reviews. So just keep that in mind. That's how the data is structured. So you can open one if you're using Spider, and you can actually just read what the review says as well. And you guys should be familiar with what test and train means in this regard. Are you able to, everyone who's coding along, have you been able to get all these dependencies running? The way to do this in Spider is you click on run, and then we're going to run by line. So it's going to be F9 that we're pressing. So you make the selection and then you just press F9 and it'll tell you if these were imported successfully. So let me know when you guys reach this part, and you can also import the text files as well. In this exercise, we're going to go through cleaning the data. So, and we're going to do very limited cleaning here. We're going to do vectorization, then we'll do the test train split, then we'll use logistic regression. So this is a great thing for you guys to do, like code along with everyone. So to make sure that the concepts are very clear and you can see machine learning at work. Has everyone been able to import the dependencies? Hello?
Yeah, no, guys, give some response here.
Okay, what idea of how many people are going to be coding along, or are you just going to listen? So then I can pace myself like that.
So anyone is coding along. Only those who's coding along, can you unmute and say yes, please?
At least I am listening.
Yeah, I wish to code along and just catching up.
Okay. Anyone else other than Partha coding along? This session is a Codeathon session, team, right? So the idea is.
I think somebody else also said they are coding along.
I think it was Sanjay. Sanjay said you're listening, right, Sanjay?
Yeah. I am listening. I am not coding.
All right. So majority is listening. Start, so you can pace it accordingly. Yeah.
Okay, thanks. So I'm going to run line by line, run through this code and tell you what we're doing. So these are the dependencies that we're going to be using. Again, the primary ML library that we'll be using here is scikit-learn. So that's the primary one. Again, you can use any library, but scikit-learn is it works pretty well there. What I do over here in between lines 18 and 24 is I take the text of the reviews and I put them in a list. So now a list is composed of strings. You can see the type over here, and each string is basically one whole review. And I've already told you how these are structured, where the first half are positive, the second half are negative. Now, the first step, as we've heard before, is before we do any sort of machine learning or data science, we need to clean up this data. Like, so what are some of the issues that exist over here in the data set? Well, firstly, we're dealing with Python, which is in this case, it's case sensitive, right? So one really obvious thing we'll need to do is that we can either lower all these letters in the text, or we can upper them. In my case, I'm lowering them, but it doesn't really matter. It needs to be the same. Otherwise, it won't be able to match words. So if you write, for example, let me find a word here. The word friends over here. If you have another word that's friends, but that's starting with a capital F, then to Python it won't make sense. I think those are different words. So it's important to lower them or upper them. The next issue that we have with these reviews is that there are a lot of special characters over here. Now, special characters could be like exclamation points, question marks, and all of that. Now, in a very advanced ML model, we might actually want to include those, but because this is more of a simplified model, we want to replace those, right? So when we replace those, there are a few rules here, which is how you want to replace them. Do you want to replace them with a space, or do you want to replace them without a space, right? So in the case of special characters, the way they're put in text is a way where you'd want to remove them without a space. Now, what is this string, right? Can you guys see the code, or do you want me to increase the font?
It's good enough. Thank you.
Okay, great. So what this is called a regular expression command. And if you guys, a lot of you, I'm sure, already have know of regular expressions, basically communicating to a computer a certain pattern in the text which allows the computer to pick out that pattern. And if you're going to do any kind of NLP, any kind of data cleaning, then regular expression is very important, because that's the basis of all the data cleansing that you're going to do. One tool that I do like to use for this is this free website called Regex 101. What you can do here, put a test string. So for example, so if I want to detect the word the, right, the regular expression command is very simple. I just write the, and it's going to pick out that match, right? Let me give you a different example. Now in this case, I'm trying to detect the in the text, and the default setting that you have on this website is that it's going to match multiple, so it's going to do multiple matches. Now let's say in this case I want to only detect this one and not this one, right? So how do I do that? Well, I can go here, I can search here for word boundary. It's told me the command for it. One second. So here, when I tell the computer that I'm only looking for the word the, where before the we have a word boundary, it's only going to detect this one, it's not going to detect this one. So there are a lot of these regular expression commands. You can really have any kind of text over here, and you have some kind of pattern that you want to detect in the text, and you can build those regular expression commands here, or I'm sure there are other IDs for it as well. And then you can also export the script. Let me just check where the functionality is for that. Maybe the website has changed, but oh, there it is. So you can just basically get the script for the regex command you just applied. Right, so this is a tool that is very useful when you're dealing with NLP. And over here, this is very like simple regex, where we're getting rid of special characters, we're getting rid of other special characters, but in a way that they're replaced with a space rather than without one. So for the people who are coding along, have they reached till line 28?
Well, I have a lot of errors in there, so I don't think I'll code along at this time. I'll continue later.
So what are the errors? Are they import errors, or are they errors in line?
Yeah, just as you see on your screen on the left, there are these triangles with exclamation marks. I see the same here in my screen also.
Is the code running though?
I just clicked on run.
So we don't do. So we're not doing run here. What you should do is make this selection, and then are you using Windows?
Yeah, I'm on a Windows.
Press F9.
Oh, F9.
Yeah. Are you using Spider as well?
Yeah, Spider.
Okay. So what we're doing with this exercise, we're going to run line by line. These errors, some of them, because I was working on this, I might have imported a library that I didn't end up using from scikit-learn. So if you have scikit-learn, I don't think these errors should be there. You just need to do run selection or this command, run selection or current line, and the shortcut for that is F9. Was that able to work?
Yeah, I get a file not found error, no such file or directory for full underscreen trained or text.
Okay, so now so now you're talking about this, right? Hello?
No. I just ran F9 on the first selection.
On this selection?
Yeah.
Okay, that's then there's probably something wrong in how it's set up, Spider.
The data file should be in the same directory as main.py or because
No,
it's in a subdirectory.
So it depends, right? So on Spider, you have this, and this is good so people can learn how to use the IDE as well. So you have this line on the top.
Right.
This is the address of where Spider is currently looking at. So if you're pointing to the directory where fulltrain.txt exists, then you don't have to write anything except fulltrain.txt, right? If this is not pointing somewhere else, then you'll need to either go into that directory if it's in a parent directory, or you'll have to specify the entire directory of fulltrain.txt. So the easiest way is to make sure that this directory is the directory where fulltrain.txt is stored. So then you can just import this directly.
Okay, so that is in a subdirectory. It's not in the main dot. So I have to change the point. Okay.
Yeah, you can just get this pointing to the right directory then.
Okay, so it's under movie_data.
Just for a clarification purpose, on line number 19, I can specify a full path of this full.
Yeah, you can.
Okay.
The only issue you might get if you do that is sometime, I don't know if you're using Windows or Mac, but you might get some kind of error on the way the path is structured by default in
Backslash or
Windows.
forward slash, correct?
Sorry?
That's
Backslash
fine.
or forward slash, like.
Yeah, so you can just, rather than changing all the backslashes,
Okay,
you can just do R over here. It's going to be the same thing.
You can just use a relative path, right?
Yeah.
So which line was that? Line 19, you said? Oh, okay. Okay. So that's, you can put movie_data on that. And then do you need 2 slashes to? Okay, let me try that.
Again, the easier way would be to just do the regular path using the regular slashes and then just putting R over here.
Okay, now
this R tells the computer that to convert those into double.
Okay, it's done. It's running.
It's running. So
I don't have any. I still get that. How do I get rid of this console? Messages first.
Yeah. So if
How
you're
do I
able
clear
to,
this?
You want to clear the console?
Yeah.
I mean, you can do that, but it doesn't really make a difference, though.
Yes. Okay, I'm here. I selected this. Okay. So after the first lines, you run this one, you said.
Yeah. So you can see the highlighted code that you should be able to run all together with F9.
Yeah, now it doesn't find full test.txt because that is running differently. Okay, that path also I have to change then.
Yeah. Okay. So so while you do that, I'll just give an overview of this function.
Okay, you can please continue.
Yeah. So RE is basically regular expression. I think it's a part of the standard library. If it's not, it's probably included in Conda as well. And what we're doing in compile is we're giving the regex command here, and then we create this function. It's called preprocess reviews, where we take the re.compile and we apply it to our lists, or the list which contains a string. So what are we doing over here? We take this compiled regex expression and we make sure that we're replacing everything that's mentioned here without a space, right? So it's replacing it with nothing essentially. And at the same time, it's also lowering the text, which means everything is now going to be lowercase. And then we do the same thing over here, except with this matching command, we replace everything with a space. Let me run this, and then it returns the reviews. And then we apply this function to these new lists, which are reviews train cleaned and then reviews test cleaned. This might take some time. So now let's look at one of the cleaned folders, cleaned list. So now you can see the text is all lower, and all the special characters, if they were there, they're all gone, right? So this makes it a lot easier for us to extract information from the text. And because it's easier for us to extract information from it, it's easier for us, for the computer, for us to tell the computer what to do with it. Now, the next thing we're going to be doing is something called count vectorization. What that essentially means is that we're going to have a very large, in this case, a very simple matrix, right? Let me show you like a visual. I found this picture online. So what we're essentially going to do, we're going to have a very large matrix with ones and zeros, where over here will be all of the words that exist in the entirety of the data set. So all of the words that we have will be the columns, and for each review that we have, we'll have a vector, right? A vector is basically the only way we can tell a computer, in this case, what this text contains. And what that vector is going to have is wherever there's a word match, it's just going to have a 1 there, right? That's all it's doing. You could theoretically have a much more complex vector for this. So you could include, for example, on this axis, you could have something like the time or something like that. So for example, if you want to detect the word cat in the text, maybe it's not the first word, but it's the second word, right? So that is going to be a more sort of thorough NLP analysis. In this case, it's a very simple one where we're just trying to see what words exist in this. We call this a corpus, right? So you have a corpus, which is a way to think about a data set of words. And if you take one review, which of the words in the review are also the same as the words in the corpus? That's essentially it. So each review will have a vector that represents itself. Okay. Any questions from anyone up till here? We've gone through the part of data cleaning. And again, the more you clean the data, the better this analysis is going to be. Any questions so far? Partha, were you able to get it to run?
Yeah, we are up to line 35 has been run and it's fine.
Okay, great. Yeah, so if you're able to run up till here, I don't think you'll have any issue with the rest of the code. Is there anyone else who was trying to run this but had some issue? We can resolve that right now very quickly. Okay, so let's start with the count vectorizer. So CV, we assign CV to the count vectorizer. It's part of scikit-learn. We imported it in line 9 here. And then within it, we fit our cleaned reviews that are for training. I think these are just the settings here. Again, you can change these settings right now. We didn't change them at all. Now, what is target over here? Target is essentially us ensuring that we want to detect sort of positive ones, right? So the first 12,500 are going to be the positive ones, which is why we're sort of filtering those out. Now we do a train and test split. Now, the reason we want to do this is we have this data set and a certain, 1 second. Yeah, so what basically this means is what we want to do is we want to, usually when we have a data set, we have to make a decision on how much we want to train the model on and how much we want to test the model on. So the way you would make that decision is there's no fixed value here. So for example, if you have less data, you'd probably want to train on a lot of data, and then you'll have less validation, but at least you know that you don't have a garbage model. So that's something to keep in mind. There's no fixed value. Some people say that it should be 50-50. Some people do like 60-50. It doesn't really, there's no fixed rule there. That's fair. There seems to be some error here. Let me try to figure it out. Where is it picking X from? Oh, I forgot to run one line here. This is the transform data.
Even with that, I am getting an error.
I think you probably didn't run line 43. Or you need to run it all together, not like line by line, I think. Okay, now C over here is something that we haven't studied yet. It's called a regularization parameter. So essentially what we're doing here, and I won't get into details here, but we are imposing a penalty on overfitting. So again, we won't get into regularization over here, but in the last class, we talked about how we can optimize machine learning models, right? And the way we do that is by playing with parameters. So I don't know, looking at this data, what the value of C should be, right? Maybe if you're a PhD in mathematics or something like that, you can make that calculation using some methodology. But what I'm going to do is I'm going to try to run this model for every value of C, right? And again, I'm not running every value of C, I'm running a few of them, but you can increase the accuracy of this by running every value of C. And after we run every value of C, we output the accuracy of C. Accuracy of the model based on a given C value. So you can see based on this that the optimal value of C should be 0.25. Right. There. Let me just check it. Actually, no, 0.5 is higher.
It should be 87632, right?
Yeah, 0.5. So now again, this is the value of accuracy based on the C values that I've provided it. There might be C values hidden here that actually have higher accuracy, right? So when you think about a more advanced model, the more advanced model is going to be able to play with more of these parameters to find one that leads to the highest accuracy, right? So again, that's one way of increasing accuracy. You could theoretically, instead of putting these values, you could literally just do for E in range, and then you can start the range from like 0.01 to 1, right? This will take a lot longer, but you'll have a higher probably will have a higher accuracy because you'll run through more values of C. You could theoretically do this for a lot of different parameters to increase the accuracy of your model. So now we have the optimal value of C. Let's run the final model and see what accuracy we get here. So the final accuracy that we got was, like you said, 0.8736. What that basically means is from our testing data set, we were able to detect the correct positive review 87% of the time. So I'll get into some more details now. For the people who are coding along, were you able to get to this part?
Yes, I've been able to get to the part. My figures are slightly different that are coming here. I get a final accuracy of 0.88156. Maybe because you changed some parameters there, I guess.
That is interesting. It could be that you're using maybe a different version of scikit-learn, which maybe is more optimized or something like that. That could be one reason for that.
Okay, no problem.
What is the exact value you get?
I get final accuracy of 0.88156.
Okay, that's interesting. So now what we can also do is, because we used scikit-learn, when scikit-learn builds this model, it has certain attributes of itself as well. So for example, feature names is one of them. So what we can do is we can actually figure out what the best words are to this model. So you can see that the positive words that it's detecting is a higher value associated to it. Yeah, one thing I didn't explain here is that what this model is doing sentiment analysis by looking at the positive reviews. So it's basically trying to see how well it can detect the positive reviews. That's an important thing to mention. And what we assume is that if it detects the positive reviews, the ones that it didn't detect as positive are negative reviews. So you can see that the best features that consist of that indicate a positive review are words like excellent, refreshing, perfect, superb, and appreciated, which makes sense, right? Again, this model is only looking at the type of words that's there. It's not looking at how those words are structured or how they're arranged. So it's not looking at what word comes first, what word comes at the end, right? So we're looking at a very simple vector over here. When we deal with something like spaCy, like a deep learning library, it looks at much more than what we're looking at right now, which is why it's able to get more accuracy. The same thing, let's do the negative reviews, negative words here. And as it makes sense, these are words that we've detected which indicate a bad review. So worst, waste, disappointment, poorly, and often. Any questions so far?
No,
Yeah, one question.
I'm good.
Could the difference in the accuracy be based on just the, I'm assuming that the weights are probably randomly assigned, right, in the backend for the network, and maybe there's a difference in the random weights that are assigned for you and for Partha.
Yeah, that's why I said there's probably there is some level of randomization that happens in the back end of this, and also other thing is that we're using a vectorizer that's already pre-built, and we're using a logistic regression model that's also pre-built. So it could be that the scikit-learn version that Partha is using is probably using a logistic regression model that is just better, right? So that could be one reason. The randomization, theoretically, I don't think it should have that big of a difference. If it was like a few points here and there, it would make sense, but the difference is large enough that it's probably because of a more optimized logistic regression model in the backend that's running with scikit-learn. I haven't updated my system in a long time, so that actually makes sense. Partha, when did you download Conda? Like, was it before when this class started, or was that?
Yeah, when probably the second week of when this started.
Okay, so that's
probably about
much more.
3 weeks back.
Yeah, it's probably a much better logistic regression model that you're using. Any other questions? So for this exercise, I did want to give a assignment slash. I mean, you don't have to do it if you don't want to, but it is something to think about, which is if you have this model here and we have this technique here, what are some of the ways we can improve the accuracy of our model, right? So let's like open the floor up for that discussion, right? So I've showed you how this model is working line by line. What are some ways working within the confines of this kind of vectorization and this text? How do you think are some of the what do you think are some of the ways we can improve the accuracy here?
Yeah, I have a question, or rather an observation. How do you use this vectorization to actually filter out comments that can, on the face of them, appear to be saying a good review, but actually is a sarcastic way of saying it, of putting things in such a way that it's actually a bad review? So
Yeah,
how do you figure in or count in the sarcasm that comes in many of these reviews?
yeah, that's a good question. In this case, this model would not be able to pick up sarcasm at all, right? It just won't be possible.
Right.
Because but there are models like the Spacey model that they say does better than picking up sarcasm than most models. And what they do is they look at data sets which exist of sarcastic uh, text, right? So what they're able to do, they're able to study the sarcastic texts specifically, and then try to find those same features in this data set. So to make that kind of model, it'll be better to make a model which is detecting sarcasm only, right? If that model is successful, then you can actually apply this in this kind of exercise here. But in this case, we aren't detecting sarcasm at all.
Okay, does this vectorization have anything to do with how to go about such cases where words are said, but they probably mean something different?
Yeah. So what
juxtaposition of words is what this vectorization is about, isn't it?
Yeah. So theoretically, if you look at this vector, this is a very simple. In this case, like 2D vector at most, right? I think this is like 1D actually. But you can imagine a very complex, multi-dimensional vector where you are trying to map a lot of relationships. For example, you might have a sarcastic text that has some sort of pattern to it, right? So that pattern should be picked up by the vector. Maybe that pattern is one where the sentence starts with a certain word and at the middle you get another certain word, right? So there has to be some way that you can detect that pattern. So if you have a complex vector, you can probably do that. But again, that's something will you need to know what these you need to have a data set where these patterns exist, and in some cases they're easy to find, in some cases they're hard to find. But you can detect sarcasm with this kind of vector, which is just looking at the actual words that exist.
Okay, thank you.
Any other questions? Does anyone have a suggestion on how we can improve the accuracy of the model that we have right
I
now?
think line number 52, like if we can increase the range, right? So maybe that might help you to create some kind of more accurate, right?
Yeah, that's great. Let's see if we can do that right now. Just want to see if the notation is correct. The solution to this would be you do 1 and then you do 100. Now we have this list that goes from 1 to 99. What we can do now is we'll have to manipulate this list so that we can get the decimal numbers. Let me just do that here. Okay, so we have this. So is this what you meant? Running all these values of C?
Yes, correct.
I hope this doesn't hang my computer, but we can give it a shot.
That's what I was thinking. Maybe it might take a long time.
Okay, we're getting all the values. We probably should have also had a way to detect the lowest, like make a function that detects the highest value of C. But yeah, this is a great way where you can just use computation to increase the accuracy of the model by running all possible values of C. Great, that's a good suggestion. Anyone else?
And is it way like I have just one question? Like, can we do like this processing multi-threading? Because in a Python we can do that, right?
Yeah, in Python you can do that, but it's going to be a lot more code if you're going to do that. So there is multi-threading in Python. There's a multi-process module, I think, in the standard library which you can use for this.
But if there is like a kind of, if we really need some kind of more accuracy, then we can trigger that one, right?
So again, when you use a library that's already been built, those libraries already are doing the multi-threading, right? That's why they perform so much better than code that one person might make himself. So yes, that's certainly true. So whenever we're utilizing like a deep learning library like NLP or like Spacey, for example, the multi-threading is already happening in the backend, right? Because they've optimized for that. But again, multi-threading won't increase the accuracy; it will make the process faster.
Yeah, that's the thing. Like we can have like a faster calculation. That's the goal here.
So another way that you can actually improve the accuracy over here, which I did mention slightly, is in the pre-process phase. What we see here is that okay, let me stop this process. A lot of these reviews here have something called stop words. So these are words that, whether we have positive or negative reviews, these words don't make sense. So aren't important to us. So for example, the word and or is or the word just
A, R, and like those kind of, like some better filtering in the regex, right?
Yeah. So what these words are, there's a word for them. They're called stop words, right? So if we have a way that we can get rid of the stop words in this data set, it's probably more likely that we'll be able to increase the accuracy, because the signal that's given out by these indicators that signal will be more pronounced. So as an exercise for people who want to try it out, I would recommend that you try to get rid of the stop words in this. You can just Google how it's done, removing stop words from text. It's a very simple process. You'll have to import, I think, NLTK for that. Do that. Use this methodology that we did for different values of C, and try to see how high you can get the accuracy. And if you think that you can get the accuracy significantly higher, just post it on the GitHub as well, and we'll review it during our next session.
Yeah, or maybe like, is it possible like we can eliminate those nouns, because nouns, like, of course, that's kind of like a stop word for me, right?
Yeah, but then you'll have to, so you can also make it like a text document which contains all the words you'd want to remove, for example. You can do that. Within NLTK, there's a method that you can detect nouns, right? Proper nouns and all of that. So you can use those as well to get rid of those. So for example, the word here, Gene Collins, it serves no purpose here, right? For positive review or negative review.
Yeah.
It might, maybe if you do in-depth analysis, you find that it's more likely for positive reviews to have a noun, but in this simplified method, we should probably get rid of it. Right?
Yeah,
So
it's like
again,
Partha was asking, like, if there is some kind of like sarcasm there, then in that case we cannot eliminate those nouns and something, right? So
yeah. So again, that's one exercise I want all of you to try. You have a very simple script over here with a very small pre-processing phase. So just try to figure out ways that you can improve the accuracy of this model, and whatever you do, upload that word to GitHub and just text me the highest accuracy that you were able to achieve, and then we'll go over the most accurate version of this in our next session and see how that was achieved. I haven't tried it in other ways, but it'll be interesting to see how you guys are able to tackle this. Great. Any final questions?
Would having more data in the training set as compared to test set help? Like you change the ratio?
That would obviously help a lot. But for this exercise, let's just do this data, because this is more about how we're doing the data cleaning, data processing, rather than the size of the data set. Obviously, if you have a bigger data set, you'll have more labeled reviews, and so you'll be able to detect more signals.
No, I meant even within this data set, like you said that right now it's a 50-50 split between training data and test data, but maybe you could make it 75% training data and 25% of this data set as the test data.
Yeah, you could do that. You could make, that's a good point. You can make a algorithm that would run the analysis for different levels of splits, right? And then you would try to find the accuracy, the split level that would get you the highest accuracy. Yes, that is a way. That would be a lot of programming, but that could be done. Yes, that's a good suggestion. Also, this is, I'm sure as you all know, this is an example of supervised learning because we have the label data already. Great. Any more questions before we close? Can I get an indication of how many people are going to try this out?
I'll try it.
Yeah, I will also try it.
Okay, great. Thanks, guys. Kader, do you have anything to say before we close?
No, all good. Excellent session, Saad, and looking forward to your next session.
I have one question, Saad.
Yeah.
And do you have like can you suggest any like alternative to like Spider and Anaconda?
So the reason for data science I use Spider more is because of the IDE over here. So I can go here and just click on the list that I created and explore it, right? So that's something that I find really useful. There are a lot of other IDEs for Python. I think Atom also has. Atom is a very clean IDE that uses, and it's a very lightweight IDE. I think that has support for Python as well. There's also VS Code and all of that. And when you are programming in Python, it's probably better to use something like a VS Code because it has a lot of extensions and everything. But for data science, the reason I use this is because I can actually see the data and like scroll through it very easily here. But you can use any IDE for this. Atom and VS Code are two of note.
Yeah, both VS and IntelliJ have got quite a number of plugins for AI, and whatever. Yes, it's just a choice of what you want to use.
Yeah.
If you're already used to one of these IDEs, you can continue to use them, I guess.
Yeah, that's correct. For VS Code, you'll have to get a lot of extensions to set up the system the way you want it to work. So that's just the one thing.
Same thing with IntelliJ also.
Yeah. Great. Any more questions before we end?
Hi. One question regarding the tool. In Microsoft Azure, which would be the preferred tool? Like, is it Python or PowerShell or some other for the data AI?
Are you talking about in Windows or on Azure?
Azure, Microsoft.
I'm not very familiar with how this works in Azure. So I don't know if Azure has cloud IDs. If someone can correct me. Someone can tell me if that exists. I don't know if cloud IDs exist.
I don't think Azure is having any kind of like that kind of IDE, like which runs like a Python code. Maybe I'm wrong, but
Okay.
as far as I know, like there isn't any IDE there.
Okay. Yeah. So when you make a deep machine learning model, that you can deploy it in Azure, but when you're building it, you have to use an IDE on your computer. There is cloud notebooks that you can use, which is basically an IDE that's hosted on the cloud. So Jupyter Cloud, I think, is something that does that. So that is an option for that.
I think even from the VS Code, you can run in a cloud.
Okay. Good to hear. Okay. Any other questions? Great. Let's close the session. I would love to see what how you guys play with this and get the to increase. Once you're done, just message me the accuracy and I'll pick the highest one. Great. Thanks, everyone. I'll see all of you next weekend.
Thanks, Sad.
Thank you.
Thank you, Sad.
Thank you very much, Todd. Bye-bye, everyone.
Bye.